When I was like 17, I thought, Minecraft would be so much more detailed and more interesting if it had smaller blocks. But I didn't like coding. I tried learning how to code and it made me want to cry. So I gave up for a decade. But a few years ago, I started learning how to code and I actually got kind of good at it. And then when AI came out, it just got way easier. Welcome to episode 2 of Vibe Coding Minecraft. I'm going to call this series Vibecraft and I do hope you enjoy it. The way I see it, I'm not going to do extra work unless I have to. So let's see if anybody's coded up a basic design pattern for voxels in Godot. I downloaded the Vibecraft repository from her Patreon. Rachel had implemented tons of interesting features like caves and these deep valleys, as well as a lighting system that worked day by day and even a chicken. That's pretty cool. It follows you around. Nice. But it kind of feels like this isn't well optimized. I want something that's a little bit stronger on the terrain generation side with something like dynamic chunking, or at least the foundation I'm going to need to build something dynamic that's going to run at a high frame rate. I decided to go on another hunt for a better repo that I can use as a starting place for my project. I did a little bit of searching and that's when I found MakerTech's project where she explains how to create complex worlds using voxels. And the most recent video is a chunk-based system that looks like it could be dynamic. So this is actually where I made episode 1. So if you want to go watch episode 1, it's probably uploaded right before this. So the first problem I had was that MakerTech left the camera in the sky without the player controls active. I thought this would be pretty easy to fix. I just asked Gemini, and Gemini told me set player visible to true. That did nothing. So after a couple of prompts, I did finally manage to be a player landing on the ground. My camera cut out there for a second, and check it out. It worked. We are back in the world. It worked. Like the last response, it was able to figure it out. Now we can run and jump and walk around. And better rendering, would be nice too, because right now the lighting is just, it's not great. So I've conquered the first challenge. The game is technically playable, and I want to start fixing the lighting, but I shouldn't do that until I first add textures. I just asked Gemini, I said, hey, if I was to update the block colors and give it some, new blocks, how would I do that? It's like, at the moment you've just got these hard-coded colors. And I was like, well, I would like to use PNGs. And it's like, you can't do that. You got to use a sprite sheet. Oh, duh, of course. I said, well, how does Minecraft do it? And it says, well, that's a fantastic question. Minecraft basically lets you just load in these files, so it's really easy as a user. It finds all the assets, all the PNGs, stitches them together into one single giant image, and then this texture atlas is what it uses to create a map in the memory, and it uses that to load the textures at runtime. So that's my next challenge right now. I don't know how long this is going to take. It's about 8 p.m., and I'm going to see how long it will take to actually implement it. I've never used GDScript really in depth, and we'll see if I get hilariously stuck or if I'm able to just wing it and actually get that amazing easy way to update the textures for the blocks. So I got some beer at this brewery and got a bit of pizza, and I ran into a couple questions like, okay, well, how big are the textures going to be? What's the resolution? And I did a little research on texture resolution and decided that 128 by 128 was going to be the best size. I think it's the closest to original N64 graphics, which is kind of what I'm going for. Amazingly, it only took 2 or 3 prompts and some pizza and beer for Gemini 2.5 Pro to get this system implemented. We now have a system where we can easily add new textures and they're added to the map and loaded instantly, and all I have to do is update a file on my computer, which from a workflow perspective is extremely powerful. And it's exactly 9:08 p.m. Okay, now we can move on to lighting. A couple of days ago, I asked ChatGPT, hey, how does the lighting in Minecraft work? I don't really like that fancy style that all the kids are doing these days. It's just gross. Because in my opinion, when you get to the point where you're trying to make Minecraft look like real life, you need to touch grass. I like the old school Minecraft, the vanilla Minecraft look. It just feels so simple. I really want something like that. How does it work? So I set to work changing the lighting, and I basically just took the GPT-4 description that I got, and I used that to craft a basic plan that I could give to my cursor agent, which in this case is Gemini 2.5. After Gemini worked its magic, I tried playing the game, and it seemed like it wasn't working. Like the game would just get stuck, and I wasn't sure what was wrong. Further investigation revealed that Gemini had created a thread lock problem where multiple threads were fighting for the same CPU, and the terrain wouldn't spawn correctly. It wasn't getting anywhere fast. So what I decided to do was revert all the changes that Gemini made and give the same original prompt and plan to GPT-5 and see what I would get. And it works. GPT-5 one-shotted it. Like, it just tore through all of that. It took like 5 minutes, and it just did it, man. Some blocks are missing, but like, I'm flabbergasted. That's genuinely impressive.
Okay, quick recap of the game so far. I mean, this kind of looks like Brains, which isn't great. But honestly, like the game is running so smooth. Like I have OBS running, and like the only thing is like the chunks are taking like forever to load, which kind of sucks. But even once they are loaded, it's still really, really smooth, which is really incredible. There's a problem with like, look, I can jump and then I can still move around, which doesn't make any sense. Also, the camera is like on the ground, which isn't great either. But yeah, overall, we're actually making quite a bit of progress here. Let's see what else we can do here. Whoa. Whoa. No, I fell off. Well, there we go. There's our first, like, huge chunk. Okay, let's see what we can do here. Okay, it's now loading really fast. Great, but there's no textures anymore. Why is that? Each block had its own texture, but now all the blocks are just green. It says the textures disappeared because the worker side UVs were built before the Atlas and UV map was ready, so every face defaulted to a single rect color. So we're going to wait for the texture Atlas manager to finish generating before snapshotting per block UV recs for workers. Wow, thanks. So great. Thank you, AI. Hey, it actually got that correct. Damn, it's a lot faster now. It's much faster now. Whoa, look at this. Look at this. Look at this. It's so much faster now.
But I wasn't done yet. I want more speed. So I started working on greedy meshing because that seemed like a good way to optimize the terrain. And I ran into an absolute debugging nightmare that lasted pretty much the rest of the night. The problem was basically that the wrong faces were being unwound on the wrong sides of the blocks. So I created a debug mode with the help of GPT-5 to try and figure out which sides of which faces I was looking at. But I got really confused because I would look in different directions and then the colors would change. And frankly, my brain is just not designed for this kind of math. It's not my favorite thing, and I got stuck. So I went to get a beer and have a hot dog and think about my life's problem. I tried again that night to fix this bug, but I still couldn't get the faces to unwind properly. My computer died, I started having a panic attack, so I decided to go to the gym because it's impossible to have a panic attack when you're working out. Got some sleep, woke up, and then I'll tell you what I did that actually fixed the bug. Ready for this?
Holy shit, I think it worked. Look, the faces are all showing correctly now. No way, dude. No way.
So without going into too much detail, and again, I don't know if you guys want this detail, but I took, like the technique that I used to solve this is that I had Claude, a fresh Claude chat open, and I would tell Claude, hey, this is what I'm dealing with. I've tried a bajillion things. Here's a report written by the GPT-5 LLM, and it's not solving this problem. We've been going in circles since last night. What should I do? And it's like, okay, classic problem. Just try this. And I'm like, okay. And we went back and forth like that. We went from Claude to GPT, and basically I had Claude coaching GPT-5 with the code base, and then I take the answers that I got from GPT-5 and augment those with my own information and give that back to Claude and just go back and forth like that until we were able to get this thing solved. And of course, the final result is that the faces are culled correctly. The faces are wound so that they're always in the correct direction. And I'm ready to end this video because I have to go to work. If you enjoyed this video, thank you so much for watching, and please hit the like button. I have a school community as well that you can check out if you want to get more in touch with programming stuff. I might even upload this code so that you guys can get to it on the school community. How sick would that be?